Okay, we're gonna start the first chapter, which is biomedical introduction to biomedical image processing, or introduction to digital image processing, because it's related to digital image, as I mentioned before. Okay, this is our primary textbook or primary sources to refer. Okay, this is a very well-known digital image processing textbook, because since 2002, actually this is the old edition. You can find out the latest edition in the market, whereby you can find out actually uh, this is one of the well-known reference for digital image processing or biomedical image processing, and you will find out most of the new textbook mostly will refer to these books. Okay, it can be considered as a primary textbook or primary reference for you. Okay, so a good textbook for those who want to learn biomedical image processing or digital image processing. Like I said before, biomedical image processing course is almost similar with digital image processing. The difference is just the application. Okay, for this course, we've tried to focus on implementing the image processing or digital image processing approach in biomedical field. So but how I design this course is more close to digital image processing, because I find out that that will be more general as compared to, you know, just focus on biomedical application. When you learn in general digital image processing, then you can implement. Okay, you can open your eyes and you can see that there's a lot of applications of digital image processing in many and various application, not just biomedicals. Okay, and in this lecture we try to cover several things. Okay, we want to know what is a digital image and what is a digital image processing, and then I give you some notes there related to the history behind the digital image processing, and then some state of art example how actually the digital image processing system looks like, and then a key stage in digital image processing. Okay, what is digital image? Again, like I said, why we need to know what is digital image, because anything about this course is related to digital image, because uh, because any image you store in your computer or you save in your computer is a digital image, because anything inside your computer is we can consider as digital world. Okay, means that every data inside your computer is a digital signal. Okay, if you talk about ECG signal, if you talk about EEG signal, if you save in your computer, it become a digital signal, and that one is an example of one-dimensional digital signals. While for digital image is two-dimensional digital image. So that's why I said before, image processing and signal processing is come from the one family, whereby we try to manipulate the digital signal inside your computer. Okay, the difference is just either is it one dimensional or two dimensionals. So a digital image is a representation of a two-dimensional image as a finite set of digital value called pixel element or pixel. So here you can see that the definition is that a final set of digital value, meaning is that, again, like I said before, when we talk about digital image, is a two-dimensional digital signal. That's why you have a finite value. Okay, you don't have you don't have any continuous numbers there. Same goes to your digital signal processing or digital signal, one-dimensional digital signal, where actually that is actually come from the analog signal, and then when you save in your computer, it become a digital signal. So what is the example of digital analogs? Okay, this actually make we try to differentiate what is the difference between digital signal and analog signal. Of course, the analog signal is a continuous number, while the digital signal is a discrete number. So same goes to digital image and analog image. Analog image, they have a continuous set of value, while the digital image, you have a discrete value, digital or finite set of value. Okay, the difference is just now if you talk about image, is a two-dimensional signals. Okay, So in other words, anything from the environment is analog signals. Okay, if you see, for example, if you see anything by using your naked eyes, actually that is analog signal or analog image, which is come from this environment going inside your eyes, and your eyes process a analog image. But when we want to implement something in computer, of course we will convert that into digital signal or digital image. So that's why you need there in these pictures, okay, inside these pictures, in the slide you can see there's an imaging system there. Okay, imaging system here is the one that will convert your analog image or analog signal into digital signals that will produce the digital image. Okay, so imaging system here, of course, if you talk about what actually will convert that from the analog to digital, you learn in many courses that it should be there's some ADC there, analog to digital converter. Okay, and in our case, that the part that converts the analog signal into digital signal, sometime one of the example is what we call as a CCD sensor. If you remember that I mentioned in the previous lectures, where one CCD sensor is embedded after the intensifier inside your X-ray system. So that's why the intensifier will sense, or you give the visible light signals, which is the analog signal, where it will go and that signal will go into your CCD sensor, and once your CCD sensor obtain that signal, it will convert into digital signal, where CCD sensor will convert that analog image into digital image. So if you talk about the imaging system here, that is just assume that is a CCD sensor. Okay, there's a CCD sensor, there's a CMOS sensor. Okay, inside your camera, digital camera as well, you have that one. Okay, it can be either CCD sensor or CMOS sensor, where this thing actually will work as a digital to analog, analog to digital converter, where it will convert the analog image from the environment into digital image. Okay, so of course, one thing that you need to know is the what is pixel or pixel element. Okay, this is pixels. Okay, I think that is very common for you. Pixel is the one that represent the coordinates there. So you can see that this is how how the analog and digital image, the comparison between the analog and digital image. Okay, for the analog image, actually there's no rigid there. Okay, the shape is very smooth, because that is the actual analog image from the environment. Once it go into this system, which is imaging system, because of the limitation there and the discrete value that we define here, that is why you see you can see that the pixels there, or the image there, become very rigid, and it occupy each and every pixels there, and each and every pixels elements there will consist of different intensity value. Okay, it's depend on what image that arrive. For example, at the edge here is very dark because the actual analog image is very dark, and then this one is very bright because of the analog image that is very bright. So this is how the digital image have been produced. Okay, of course, if you talk in real digital image, digital image, real image that you find out now in your digital camera and so on, this is how it look like. Okay, it's a color image, and of course you don't see the rigids there. So why you don't see the rigid there is because the resolution is very high. So if you want to see the where actually there's a rigid bodies there, or the rigid shapes there, it is appear when you zoom the image. Okay, when you zoom the digital image, and you find, for example, in this one, okay, if you zoom in the ears of that mouse deer, you find out there's a rigid there. Okay, that is actually why we call this is digital image, because each and every pixels there is there's a finite value. This is not continuous value, which is why the shape is not very smooth. So in order to improve the appearance of digital image, that's why from days to days, every camera manufacturers try to increase the resolution. Okay, in image processing, we call that as a spatial resolution. Okay, spatial resolution. When you increase that spatial resolution, then the pixel become very small or very fine, where by the time you see the whole image, you cannot see the rigid shape there. Okay, because you see it's almost similar to your analog image, where the analog image is a continuous number, but this one is almost a continuous number because the pixel is very small and the value is very fine. So that's why your eyes is very difficult to see any defect or any rigid shapes there. But if you zoom it, then you can see actually it's still a digital image. However, it has been converted into high resolution, where it's very difficult for your eyes to see the imperfection inside the image. Okay, in general, digital image can be divided into three type. Okay, some said the three type. I think not okay. In some textbook, they divided into four types. Okay, the first one is a grayscale. Okay, and then you have a binary or black and white image. Okay, in this slide they put it in one group. Okay, binary and grayscale is in under one category, or under the same category, which is one sample per point. And you also have the color image. We have two type of color image. One is a RGB color image, another one is RGB alpha. Okay, which is you have a 4-channel color image, and you have a three color channel image. But in our program, we only focus on 3-channel color image, which is consist of red, green and blue. Okay, this is the one that I mentioned there. You have a binary or black and white image, grayscale and color image. Okay, if you go to the next slide, this is the binary image, this is a grayscale image, and this is the color image. So this one does not include the 4-channel or multi-channel. I'm sorry, the last one, which is we have a 4-channel image, where you have a red, green, blue and alpha. Okay, this one is always exists in your computer. For example, when you doing some image editing, of course the color itself, it's come from these three component. Okay, how strong your red, how strong your green and how strong your blue. While the alpha here will represent the transparent aspect of the image. If you manipulate the alpha value, then you can see that your image can the numbers or the appearance of your image have higher transparent, where actually you can see the image behind the background behind the image, like this one. Okay, so that's why that is the alpha represent the transparent or opacity of the image. Okay, but if you talk about image without alpha components, then there's no transparent effects. Okay, like what we focus on in this course, we just focus on the color image that consists of red, green and blue. But we don't process the alpha. So that's why in our course, we just focus on the second one, which is a 3 sample per point. Okay, just give you some exposure. Actually, this one is just give you some additional knowledge. Actually, instead of RGB, you also have the RGB alpha, where the RGB seems similar to the previous one, which is RGB, but you have another extra channel called alpha that will control the transparent of your image when you display on the screen. Okay, so this is the examples of your the example or the structure of your digital image, where again, like I said, in general we have a binary, grayscale and RGB color image. So this is the binary or black and white image, and this one is a grayscale, and this one is a color image RGB.